Hey there, viewers. Thanks for tuning in to the Daily Space Weather. We're bringing you some fresh imagery once again, the past 24 hours of what's going on at the closest star and beyond. From the sun to Earth and more, covered here at the Smash News Network, least busted name in news. Congratulations on realizing that the channel exists, thanks to our new subscribers, followers, those who left comments, and those who were made angry by yesterday's shorts. We have a huge filamentary fest going on and a possible new active region rising down here in the southeast, as a quite active region is in the process of setting in the northwest. The most likely place to see a large flare is probably this series of large sunspot groups right in the Earth-facing strike zone. So here's the northern hemisphere, and you may see plasma filaments. So here's a huge plasma filament here, plasma filaments galore. And these are the kind of things that become coronal mass ejections when they exit the solar corona. Don't be surprised to see some earthly vicinity coronal mass ejections. We've had sort of a shortage in the past couple of days, actually. So perhaps the calm before the solar storm here. There's the western equatorial region, filaments over there, and don't forget the filaments in the southern hemisphere. Massive filament down here, great view of that in 304 plus 193 angstroms. These images all depict 24-hour SDO videos. Huge filament over here ahead of that new active region, likely a new sunspot, forming in the next 12 to 36 hours. So here you'll see a whole bunch of plasma being suspended out there. Those look like magnetic field lines. Well, they are. The plasma orients to those magnetic field lines. Think of that plasma as tiny magnets. Here's a close-up of that active region rising. And we do have at least one new named sunspot group coming. We'll get to it here momentarily. It would be this group down here in the southeast. Besides that, things mostly stable for the past 24 hours. And we're going to show you the colorized magnetogram next. So there are sunspots, that is yesterday plus today, SDO intensitygram, and there is the SDO colorized magnetogram. Again, we'll have at least one new named sunspot group today. This is at least beta gamma class. And we're going to see what's going on planet Earth. But first, take a moment to visit our affiliate link. If you haven't seen it, it's the Hemp Lucid link that you can find below this video, as well as on the homepage. Save 10% on checkout for your Hemp Lucid order by entering the promo code SMASHOMASH. So enter that promo code, the promo code SMASHOMASH, the name of our YouTube channel, and save 10% on your checkout. So if you do see a paid affiliate / sponsor advertising rectangle associated with this video, that's what it is for. There are also some other ways to support the channel if you aren't interested in CBDs and mushroom gummies and things like that. We'll get to it in a moment. Next, let's see what's going on in terms of volcanoes right here on planet Earth. So Etna now back on the list. A sudden but minor explosion occurred from the southeast crater. Sakurajima flight level 070 over Kyushu, Japan. That's a 7,000-foot ash plume. Luwatolo producing a 7,000-foot ash plume as well over the Lesasunda Islands as it explodes. Semeru also exploding, flight level 140. Continued uptick there over East Java, Indonesia. It's a 14,000-foot plume of volcanic ash. Dakono exploding, flight level 070. Popocatépetl exploding, flight level 200. 20,000-foot ash plume over central Mexico. Revenador exploding, flight level 130, and Sabancaya exploding in Peru, flight level 210. That's a 21,000-foot plume of volcanic ash. Please do not pole vault the caldera. Next, global seismicity. We had about 5 quakes that were over a 5 magnitude in the past 24 hours. That is a convenient 90-day bar graph for you there. And let's check out the list. All right, so here's your volcano rundown. We'll cite quakes over a 5 magnitude only. A few quakes there in the U.S. They are not large enough to be covered in this video. Although feel free to leave us comments if you do have things to say about the U.S. quakes. There was a 5.2 at Japan. That was at 14:03 Universal Time yesterday afternoon. We also had a 5.1 at the Molucca Sea. They're north of Australia. That one was at 15:32 Universal Time yesterday afternoon. Another 5.1 here, a little under an hour later there at Japan. If we miss anything on the list, just let us know in the comments section. And last but not least, a 5.3 at Argentina. That was at 7:39 Universal Time this morning. And let's get back to space. Before we do that, we'd like to encourage everybody who sucks at science to do the math. If you're believing a lot of nonsense on YouTube, and there are all kinds of scientists and other experts telling you that it's nonsense, well, how about learn to do the math? If somebody's citing a science paper to back up their ridiculous claims on YouTube, maybe, read the abstract and the conclusion of the science paper at least, even if you don't understand the body of the paper. It might be very helpful for you to do any of the math. And there were a lot of herp-derps commenting on our shorts yesterday because we put up inflammatory titles on purpose. Those people are all invited to do the math also. And we like to show our work. That's an image of the constellation Cygnus in the background, by the way. And our work is 8 = capital D. If you're unable to do the math, and you're going to tell me to do the research and cite a ridiculous, nonsensical video about space weather, misrepresenting various science publications and cosmology itself, you're invited to do the math, and you're invited to check out the links below this video. You'll find links to the Redbubble shop, which is where you can find these products. So do the math, tell your friends and foes about it. 8 = capital D is the equation, and great job, Big Tech. Big Tech doing a fine job at doing the math, just a fine job. Slow clap for Big Tech. Well done. Well done. They did the math. 8 = capital D. Big Tech. 10.7 centimeter radio flux is now at 140 solar flux units. That radio signal comes out of the upper chromosphere and lower corona right there, a very thin portion of the solar atmosphere. The area above the surface, known as the photosphere, and below the atmosphere, known as the corona, is the chromosphere. The upper portion of that and the lower corona is where the radio flux emanates from. There is a 1-year graph to put it in context. We're talking about this black line here. That is the 10.7 centimeter radio flux over the past year. The red line is the sunspot number over the past year. NOAA's not forecasting any geomagnetic storms or geomagnetic unrest conditions, and I would tend to agree, as there is not a lot of space weather in the current forecast. Although that can change rapidly, which is why we do the videos daily. Next, Earth's magnetic moment for the past 4 hours. It's Earth's magnetic moment from space, our geospace magnetosphere movie depicting magnetohydrodynamic pressure. Again, that's the last 4 hours of Earth's magnetic moment from space. You could say it's Earth's geomagnetism. Earth's geomagnetic field depicted here by the space weather modeling framework for the past 4 hours. Here's Earth's magnetic moment from the ground. You could say this is Earth's magnetic field. Ground magnetic perturbations map depicts geospace delta B. That is, changes to Earth's B field in nanotesla would be the units depicted here. That is Earth's magnetic field from the ground level Things are geomagnetically calm. Continuing on with geomagnetic conditions, KP index currently at 1. Again, no storms in the offing here at the moment. We're not expecting any space weather until something changes. And it always suddenly does, which is why it's exciting to put out these videos daily. As far as the real-time solar wind data here, it's a little bit uninteresting. Yeah, it's a fairly unimpactful last 24 hours as far as the solar wind parameters. You're talking about 466 kilometers per second for the solar wind velocity and a solar wind density of 6 3/4 protons per cubic centimeter. Next, how about our GOES magnetometers? There are the readings from the GOES magnetometers, and they are quite smooth here. We are seeing the continuing subsiding of a rather weak coronal hole high-speed stream. And let's move to Earth's magnetic moment. Let's move to the heliospheric current sheet. So there you go. There is the heliospheric current sheet depicted in polarity. North Pole current sheet, which Earth just left, depicted in green. South Pole current sheet, which Earth just entered, depicted in red. So there is your North and South Pole current sheet. South over here, North setting in the west. And keep in mind that new sunspot likely rising in the southeast could affect this. Let's take a look at our line of sight field plot. This will depict the sun's B field. We showed you the Earth's B field. Here's the sun's B field depicted in blue. You can see that sector boundary crossing here just moving off to the west as Earth just yesterday has entered the South Pole current sheet. We'll also show coronal holes. Those are kind of important as they illustrate the solar polar field reversal process during each solar cycle. We've got some coronal holes rotating in here, by the way. And we're going to show those momentarily. Let's just bring up the latest image and then briefly show the 171 angstroms wavelength. It's the house favorite after all. And let's add 211 angstroms to show the extended corona. That should be pretty sweet, right? So there you go. There's 171 plus 211 angstroms. And you can see those coronal holes starting to show up now. Let's subtract 171 angstroms to show just 211. And as forecast yesterday, you can see these coronal holes in the east becoming more well-defined, as there is increasingly less plasma in between you and those coronal holes, blocking their view. The magnetometers are not fooled by this. So there's the situation. We've got South Pole-oriented coronal holes over here, sector boundary crossing right about here, and North Pole coronal holes over here. Next, we'll move to sunspots. So there is the situation for sunspots. Again, we are expecting a new sunspot group to get named right down here. That'll be known as 3307. 3307, the likely name for that new sunspot group. And there's the equatorial full disk view. Some degradation happening in this group up here. This group down here, slight growth. This group here, just some slight evolution there. Some of those umbral fields moving a little bit different rates to the other fields. It's sort of a normal thing. Let's move to energetic particles. We ain't got none. As far as solar energetic particle events go, the proton flux remains flatlined. And we just did recently have, it's actually still going on here, a long duration C-class solar flare. Peak flux was about C3. and peak flux was around 8 o'clock this morning. Let's take a look at that. I suspect it might be coming from the southeastern limb. And indeed it is. A long duration flare coming from down there in the southeast as that new active region rises. I would also note that it is at a quite high latitude, meaning it's far from the equator. Another indication that we're still not at solar maximum. At solar maximum, you can expect to see sunspots at all latitudes. Anyway, current conditions are long duration C-class flare here, winding down it looks like. Most likely place to see additional large flares is probably this group up here. It's actually 3 different sunspot groups there. They do have they have complex magnetic fields, which are the type of fields associated with large solar flares. There still is some possibility of seeing a large flare from this group, as the plasma is still not out of sight, and you don't even need to see sunspots in sight, as we just showed you in the southeastern limb, to see a flare. So don't be surprised to see a large flare there, although the likelihood of that is diminishing as time goes on. And perhaps it is even the most likely to see a large flare from down here. So we are seeing quite a bit of activity already. I do suspect that is a sunspot rising. Here's a great close-up of the most recent X-ray flare. And don't get them confused, folks. A quick reminder that solar flares and coronal mass ejections are different phenomenon. Yeah, they're different phenomenon, folks. Solar flares, coronal mass ejections, completely different. I hear people getting confused about this all the time. An easy way to understand it is that solar flares are photons. Coronal mass ejections are protons. So imagine standing in front of a fan. That wind hitting you in the face, that's protons. Now imagine standing in front of a spotlight. Although those are a different frequency photons to an X-ray, obviously, those are photons. They're just at a different frequency than the X-ray type photons. Photons and protons, don't get them confused. And let's take a moment to take a look at space. Yes, space, a frontier. These are the voyages of the YouTube channel Smash-O-Mash. Is it the final frontier? I'm not so sure about that, but this is what's going on overhead at Lehigh Valley, Pennsylvania. The location of the Smash News Network, least busted name of news. That's about as specific as we'll get about it. The rest of that information is classified. So that's what's going on overhead. Did you catch Venus last night? Venus last night was at its highest point in the sky, and we did share some additional information there with our silver and gold Smash team members about that. Let's do a solar system forecast now that we've shown people what's going on overhead. You've got things like the summer triangle up there, as Deneb circles Polaris over and over again. Next, here is your solar system forecast. We're going to move things ahead 1 week as Mercury swings over to be on the gas giant side. Here's where things will be in 1 week. We will have a crescent waxing moon by the 22nd of May. And let's start looking at coronal mass ejections. So, coronal mass ejections have been in short supply over the past 24 hours. There are some outflows going on, but no major CMEs occurring here. Those are yesterday's images. Here are today's images. An additional 37 frames for you there. I don't suspect any of that is earthly directed. Let's take a moment to look at the Soho-Lasco C2 and C3. That should help corroborate this information. Things are chilling here. Nothing is headed Earth's way at the moment. We'll look at stereo A also, just to make sure, as occasionally there is some missing data there. So we'll allow the corona, the Soho-Lasco C3 coronagraph there to play on the right. Stereo A there on the left. Again, a quick reminder, the likelihood of additional coronal mass ejections is nearly 100%. We've got a crazy number of plasma filaments on the closest star. We'll show you them here in a moment. First, our custom views. Yeah, our custom views. We've got some fresh coronagraphs. And there you have it. So that's the last 24 hours. That's SDO 193 angstroms plus the Soho Lasco C2 and C3. I'm going to go out on a limb here and forecast an Earth-directed coronal mass ejection today. There are a crazy number of filaments on the Earth-facing portion of the solar disk. Let's take a look at those from El Teide, Spain. So here's El Teide, Spain's ground-based solar observatory. It's depicting hydrogen alpha. And all these dark features that you see are plasma filaments. There is a lot of suspended plasma here on the Earth side of the solar disk. So any one of these could find itself hurtling towards your doorstep. We've got filaments up here by the North Pole and the South Pole. Filaments right in the center here. And also in the Northern Hemisphere, mid-latitudes, and the Southern Hemisphere, mid-latitudes. Again, remember, folks, you don't need to see solar flares or even sunspots to see coronal mass ejections. These are separate phenomena. Anyway, here's the past 24 hours in another classic wavelength there, 304 angstroms SDO, ionized helium. And those filaments do show up in these wavelengths. Let's take a look at the last couple of hours. We should at least see the waning hours of that flare. There are the past 2.5 hours from the GOES 16 SUVI. And I guess that flare was so long ago and such a long duration that it's not actually showing up there. Let me just go back here for a quick moment. So a very long duration flare there. It's actually kind of still occurring. Anyway, it's almost time for our bonus feature segment. So let's do it. Bonus features are starting out with satellite charging hazards, of which we don't see any. It's smooth sailing for satellites at the moment. Ionosphere has calmed down a bit as well. We'll get to that. First, the GOES electron flux, which is in a low operating range here. Just low to moderate levels of electron flux there, nothing to write home about. There is the NOAA forecast model. The green boxes are the forecast. The yellow diamonds are the observation. I would tend to agree with that forecast. That looks pretty accurate to me. There is the one-year graph to put the relativistic electrons in context. Just a low to moderate level here at the moment. And let's take a look at the F layer of the ionosphere, the portion of the atmosphere where that electron flux is measured by the GOES 16 and GOES 18's radiography. And there is the F layer. Ionosphere snapping back to pretty normal levels here in the past couple of days. Is it news to say the ionosphere is looking non-anomalously? I'm not sure. Maybe that'll create some scandal on YouTube. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. And we've got more low-frequency anomalies than high. Those are depicted in red. High-frequency anomalies are depicted in blue. That's anomaly in megahertz from a 30-day median. And you'll see most of those anomalies centered around the South Atlantic anomaly located over the South American continent. There's the latest image, 11:15 universal time ionogram and 11:15 universal time anomalygram. We're also interested in the total electron content, as that gives us additional insight into what's going on in the Earth-Sun space weather system. Your GPS satellites are located at 12,500 miles of altitude, and free electrons in between them and your handset can cause signal refraction, which is what is depicted here in the total electron content forecast. We do have significant bits of electrons here out of place, although, as normal, most GPS errors you'll find happening around the equator around noontime. If you are expecting GPS errors, perhaps try using Wi-Fi location accuracy services that will help to tie known locations of IP addresses to your navigational process. Here's the total electron content anomaly from the 10-day average over North America. There are some high electron anomalies there. We'll let that play through a second time, and then we'll close out the space weather section of this video to provide you with the high-resolution imagery of the closest star. Before we do that, take a moment to press like, subscribe, share, etc. Support the channel via becoming a Smash Team member at the gold or silver level. The best value is the gold annual paid-up subscription. Were you aware of this? The best value is the gold annual paid-up subscription. It's almost like getting 4 months of a gold membership for free, because it includes complimentary merch. These videos are brought to you in part by the Smash Team, especially the gold and silver Smash Team level members. Keep in mind we make just this side of nothing to put the most detailed, comprehensive space weather and solar imagery you'll find anywhere in the world on YouTube. So we've sought out various sources to increase the probability these videos will continue to exist. The Smash Team site is one of those. It's our custom subscription services site. If you want additional content, the Smash Team is the place for you. We send out email alerts and all kinds of other features there available, especially to our Gold Smash Team members. We've also opened an Amazon shop, so check out the products there. Look for more products coming soon. Today I'm drinking Cameron's Scandinavian light roast coffee, by the way, the organic whole bean coffee. You can find that in the list. Today's featured product is being worn by me right now. Yeah, it's this Hawaiian shirt, whatever it is. There you go. I am a collector of Hawaiian shirts since the late 90s, I guess it was. And you can find some of the latest acquisitions there. Links at the Smash Team page at smashomash.com. And welcome to the Neo-Renaissance. Did you know that we're composing a paper that explains the likely mechanism underlying the solar sunspot cycles? Yeah, I figured this out accidentally by doing these videos. So help support the operations with clicks, or by visiting our Hemp Lucid shop, Amazon shop, becoming a member of the Smash Team, etc. We're doing space weather for the sake of cosmology, as I believe heliophysics is not only the key to advancing cosmology, but also human technology. Superionized materials are the future of mankind's technological basis, as well as mankind's cosmology understanding. Anyway, here are the latest images. We ain't got no new sunspots rising over the southeast limb yet, but we'll be keeping an eye on that. And let's transition from space weather to Earth weather. So what we're looking at here at the Smash News Network, least busted name in news, is the mean sea level pressure. Earth's lowest pressure is under 950 hectopascals, located in the Southern Ocean here, in between Antarctica and New Zealand. That's like hurricane force pressure in the Southern Ocean. And also some very high pressure, a little closer to the geographic South Pole. That's the mean sea level pressure. And I guess we can show the whole world view here. As winter approaches the Southern Ocean, there's the northern geographic pole. Again, that is depicting mean sea level pressure. Next, let's show wind maps briefly. Starting out with the surface winds of the eastern world. Shout out to our viewers from all around the planet. Press that share button and tell your friends and foes. Pick up some merch. And tell your friends and foes about the channel that way. Start a conversation. Here are the jet streams of the east. Jet streams of the west are looking like this. We've got incoherent jet streams over the western portion of the U.S. Every place west of the Mississippi here has got a very incoherent jet stream. I'll just say that. Here are the surface winds of the western world. Surface winds of the central world. And it's looking windy in the eastern Mediterranean. Here are the jet streams. And let's see what's going on in terms of clouds and fog. That is 3.9 micrometer radiation, part of the infrared spectrum. It depicts clouds and fog when it's too dark to use the visible satellite. If you're wondering if you'll have clear skies at nighttime, the shortwave radiation map is a definite favorite. Take a look at our weather.gov map. We've got some frost advisories here for much of New York, northern Pennsylvania, and parts of New England. Also, I think those are hard freeze. Are those hard freeze warnings in northern? Those are freeze warnings in northern Michigan. We'll show you the key and then remind you that if you've got weather warnings in your area, obtain them from weather.gov, the National Weather Service's homepage. So since we've got some cold and hot weather anomalies, we've got anomalously hot temperatures coming to the Pacific Northwest and anomalously cold temperatures coming to the central U.S. as well as the Northeast. That's your 72-hour GFS temperature anomaly forecast in degrees Celsius. There's a lot of snow that is going to be melting on the left side of that map. We've also got your 72-hour GFS pressure and precipitation forecast. There will be a strong low developing there off the coast of South Carolina in about 3 days. Besides that, fairly calm weather here across the U.S., at least according to the GFS model. And let's continue on to our lightning mapper. Some heavy lightning here around southern Texas once again. It looks like things are finally calming down for you, Texas. Hopefully you didn't receive a foot of rain. And let's take a look at a real-time lightning map to see if we've got any terrestrial strikes. Doesn't look like any in the U.S. here at the moment. Next time you hear thunder, perhaps check out lightningmaps.org. It's quite good. And if you want to forecast thunder, that's the way to do it. Hey, we've got some strikes here coming in around La Pryor, Texas. Little thunder shower kicking up there. And there's the full map view. We've also got your satellite imagery. There's a great satellite animation from windy.com, who also has a great mobile app. If you've never seen it, by the way, perhaps check that out. I use it on my device. And there are a whole bunch of interesting layers that you can watch on there. Everything from soil moisture content to The CAPE index, that's potential energy in the atmosphere. Cloud tops, low clouds, high clouds, fog, humidity, precipitation type, snow depth, etc. Windy.com. It's quite nice. Next, we're going to show you the U.S. Doppler radar, the clouds and fog over the U.S., and the water vapor map. So that's where we'll close out this video. While I initialize those segments, just take a moment to press that like button. If you haven't done so, that helps us out with the pathetic algorithms on YouTube. By the way, if you haven't seen our shorts, check out our shorts. They've been fairly popular in the past week. You can find those at youtube.com/smashomash/shorts. Anyway, here is the U.S. Doppler radar map. Here is clouds and fog. Once again, this is the 3.9 micrometer infrared radiation, and here is the 6.19 micrometer infrared radiation depicting water vapor, as in all of it. Interesting point here is we've still got this anticyclonic system, which is largely centered over Louisiana. That is a high pressure zone, and you can see this clockwise rotation, as would be characteristic of anticyclones in the northern hemisphere. Remember, folks, high pressure blows and low pressure sucks. Although low pressure generates higher winds, especially in situations like hurricanes and tornadoes, that is still a sucking force at the vortex of that low pressure. High pressure is the opposite. It's a pressing down on the atmosphere where winds emanate from the center, as opposed to getting pulled toward the center. Maybe that helps your understanding of atmospheric physics. Maybe it muddies the water. I'm not sure. By the way, there are no chemtrails visible on this map. Thanks for tuning into the Smash News Network, least busted name in news. Once again, congratulations on realizing the channel exists. And may that solar wind be at your back.